When we try to visualize the extreme limits of the human mind, we almost always start with this face: the wild hair, the Nobel Prize, the man who gave us the equation E equals mc squared. But the reality of how that mind developed is at odds with the legend. In Munich in 1884, we find a 5-year-old boy who worried his parents. He was such a late talker that his family genuinely feared he had a learning disability. His early childhood was marked by a quiet, methodical patience. While other children were playing outside, he would sit for hours, carefully stacking playing cards to build 14-story houses. The mind that would eventually reorganize our understanding of reality began its life in silence, intensely focused on observing how things worked. That focus found a target when he was sick in bed. Hoping to cheer him up, his father brought him a magnetic compass. No matter which way he twisted the brass housing, the needle always snapped back to north. He realized an invisible force was pulling it, evidence that something deeply hidden existed beneath the observable world. But his inner sense of wonder soon collided with an external reality. He was enrolled at the Luitpold Gymnasium. This school operated on a strict Prussian model. Teachers demanded rote memorization and rigid obedience, treating any independent thought as a threat to discipline. This created a tension that would define his youth: how a mind desperate to understand the hidden mechanics of nature survives a system designed to crush independent curiosity. He couldn't survive in that environment. He dropped out, fled to Italy, and eventually failed the arts and language section of the college entrance exam in Zurich. Forced to finish his education elsewhere, he enrolled at a cantonal school in Aarau, Switzerland. Aarau was different. They used the Pestalozzi method, an educational philosophy that prioritized intuition and visual conceptualization over abstract memorization. This environment allowed him to run his first major thought experiment. He imagined what a light wave would look like if an observer accelerated to match its speed, eventually freezing it in place. By escaping rigid schooling, he replaced memorization with visualization, perfecting the mental process he would eventually use to decode the universe. He eventually graduated college, but his rebellious attitude had alienated his professors. None of them would offer him a teaching position. With no academic prospects, he settled for a job in Bern, working as a Level 3 examiner at the Federal Patent Office. Day after day, he reviewed designs for gravel sorters and electric typewriters. His boss instructed him to assume every inventor was wrong until proven otherwise, training him to be ruthlessly skeptical of all engineering assumptions. His work involved evaluating electric clocks, synchronizing railway times. He accounted for the physical time delay of an electrical signal traveling between stations. Visualizing that delay, he realized 2 simultaneous events for one observer wouldn't be simultaneous for someone moving at a different speed. This patent office job functioned as a perfect worldly cloister, providing the specific training and solitary time he needed to rewrite the rules of physics. That isolation culminated in 1905, a period now known as his miracle year. He was just 26 years old. In a matter of months, he published 4 papers that would shift the direction of modern science. These documents proved the existence of atoms, established the theory of special relativity, and introduced the equation E equals mc squared. 10 years later, in 1915, he completed general relativity, describing gravity as a physical curvature in the fabric of spacetime. His math was physically verified during a 1919 solar eclipse, when astronomers observed starlight bending around the sun exactly as he had predicted. The discovery made him a household name. These discoveries corrected centuries of Newtonian physics, eventually earning him the 1921 Nobel Prize. The invisible forces that had fascinated him in his youth were finally mathematically defined, overhauling centuries of scientific logic. He spent his later years in America, established as the premier intellectual and moral voice of the 20th century. Yet, when asked to assess his own life, he insisted he had no special talents, only a passionate, holy curiosity. His life suggests that the ability to rethink reality isn't forged by perfect academic records, or prestigious institutions, or rote obedience. The foundations of modern physics were built by protecting the stubborn wonder of a 5-year-old boy trying to figure out what